The Coulomb is the international system of units unit of electric charge. It is the charge transported by a constant current of 1 ampere in 1 second. Thus, it is also the amount of excess charge on a capacitor of 1 farad charged to a potential difference of 1 volt. It is equivalent to the charge of approximately 701862420000000000006.242 times 1018 protons. And -1 C is equivalent to the charge of approximately 7018624200000000006.242 times 1018 electrons. Name and notation. This SI unit is named after Charles Augustin de Coulomb. As with every international system of units unit named for a person, the first letter of its symbol is uppercase. However, when an SI unit is spelled out in English, it should always begin with a lowercase letter, except in a situation where any word in that position would be capitalized, such as at the beginning of a sentence or in material using title case. Note that degrees Celsius conforms to this rule because the D is lowercase, based on the International System of Units, Section 5.2. Definition. The SI system defines the Coulomb in terms of the ampere and second. 1 C equals 1 A times 1 S. The second is defined in terms of a frequency naturally emitted by cesium atoms. The ampere is defined using Ampere's force law. The definition relies in part on the mass of the international prototype kilogram, a metal cylinder housed in France. In practice, the watt balance is used to measure amperes with the highest possible accuracy. Since the charge of one electron is known to be about -698116602179991.60217662008 times 10⁻19 C. -1 C can also be considered the charge of roughly 6.241509 times 10 to the 18 electrons, where the number is the reciprocal of 1.6021777 times 10⁻⁻19. The proposed redefinition of the ampere and other SI base units would have the effect of fixing the numerical value of the fundamental charge to an explicit constant expressed in coulombs, and therefore it would implicitly fix the value of the Coulomb when expressed as a multiple of the fundamental charge. SI prefixes. See also SI prefix. Conversions. The magnitude of the electrical charge of 1 mole of elementary charges is known as a Faraday unit of charge. 1 Faraday equals 96,485.3399 coulombs. In terms of Avogadro's number, 1 coulomb is equal to approximately 1.036 times Na times 10⁻⁵ elementary charges. 1 ampere-hour equals 3600 C, 1 milliampere H equals 3.6 C. The elementary charge is 6981160217662079991.60217666208 times 10⁻19 C. 1 stat coulomb, the obsolete CGS electrostatic unit of charge, is approximately 3.3356 times 10⁻10 C, or about 1/3 of a nanocoulomb. 1 coulomb is the magnitude of electrical charge in 6.2415094 times 10 to the 18 protons or electrons. Relation to elementary charge. The elementary charge, the charge of a proton, is approximately 698116620779991.60217666208 times 10⁻19 C. In SI, the elementary charge in coulombs is an approximate value. No experiment can be infinitely accurate. However, in other unit systems, the elementary charge has an exact value by definition, and other charges are ultimately measured relative to the elementary charge. For example, in conventional electrical units, the values of the Josephson constant Kj and von Klitzing constant Rk are exact defined values. and it follows that the elementary charge E equals 2 is also an exact defined value in this unit system. Specifically, E90 equals C exactly. SI itself may someday change its definitions in a similar way. For example, one possible proposed redefinition is, the ampere is defined such that the value of the elementary charge E is exactly 6981160217648699991.602176487 times 10⁻19 coulombs. This proposal is not yet accepted as part of the SI. The SI definitions are unlikely to change until at least 2015. In everyday terms, the charges in static electricity from rubbing materials together are typically a few microcoulombs. The amount of charge that travels through a lightning bolt is typically around 15 C, although large bolts can be up to 350 C. The amount of charge that travels through a typical alkaline AA battery from being fully charged to discharged is about 5 kilocoulombs equals 5000 C 1400 milliamperes H. According to Coulomb's law, two negative point charges of 2999900000000000000 minus 1 C, placed 1 meter apart, would experience a repulsive force of 7009900000000000009 times 109 N, a force roughly equal to the weight of 920,000 metric tons of mass on the surface of the Earth. The hydraulic analogy uses everyday terms to illustrate movement of charge and the transfer of energy. The analogy equates charge to a volume of water, and voltage to pressure. 1 coulomb equals the charge of 7018624000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 flow of 1 coulomb can vary. For example, 300 times fewer electrons flow through a lightning bolt than in the discharge of an AA battery, but the total energy transferred by the flow of the lightning's electrons is 300 million times greater.